PSSE is a power system simulation and analysis tool for power transmission operations and planning. With PSSE, Siemens PTI offers a comprehensive high-end analysis software solution for all your transmission system planning needs. The PSSE base package can also be further enhanced to include a rich ecosystem of optional add-on modules. There are two main ways that PSSE is run. The first is manually through the user interface. It can also run as an automation engine and an integrated part of other applications. To run PSSE manually, click the PSSE version 34 icon on your desktop. The main data file for PSSE is the save case. All other data is added and augmented based on this file. The save case stores the topology, the conditions, the generation, and so on. To explore PSSE, open an example file. Click on the File button, browse to your C drive, and select Program Files. Click PTI, PSSE 34, and then open the example folder. Here you will find example files of every type. For this demonstration, open the sample.save file. Fundamentally, a save case is a set of tables. You can view and change the data in these tables through the network data grid. These tabs show the buses, plants, machines, loads, and so on. It's common to interact with the data at this level, but usually a user has a single-line diagram with a built-out graphical display of either the entire case if it's a small case, or a subset of the case if it's a large one. Next, let's open the sample.sld. You'll often hear these files referred to as slider diagrams. These files include a graphical representation of the network. It allows the user to interact with the topology and the data of the case. Zoom in to focus on one area of the diagram. To change annotation settings, click here. For this example, we will check the box for out-of-service equipment and uncheck the Use Line Ratings box. Then click OK. Here you see transmission lines. In the center of the diagram is a 3-winding transformer. The transformer symbol also shows the grounding. There are machines, loads denoted by arrows, synchronous generators denoted by the circles, as well as 2-winding transformers and buses. The diagram shows flows. It can show animated arrows by clicking this button, or indicators like these gauges. You can see whether something is highly loaded or overloaded from the percentages. The calculation for a power flow study is the power flow solution. The power flow solution for a large case is an iterative, complex solution with a lot of controls, tuning, and so on. Many power flow engineers are comfortable with tuning their power flow solution according to their case and their needs. This is an unsolved case, which means it has an initial solution, but it may not be up to date. To solve the case, click this button, and then click Solve and Close. Fundamentally, a solution for a power flow case is the set of voltage magnitudes and angles at every bus in the case. From this vector, you can derive flows, currents, megavar inputs from generators, and any other quantity used to monitor the state of the system. Based on the settings of the diagram, flows are noted numerically at the terminals of the buses. There are several ways you can interact with the diagram. For example, you can switch this line out between these two substations, then resolve the case to get a solution based on the new topology. You may have noticed this gauge is now red, and the loading of that line is 105%. The power flow increased to compensate for this transmission path, which is out. These are the types of interactions you can have with a graphic power flow solution and model. PSSE also has a node breaker topology processor engine, so any bus can be associated with a node breaker substation model with lower-level topology details. Let's drill down deeper into this bus. You can interact with this diagram by opening and closing breakers rather than just opening and closing branches or lines connected to terminals. There are several ways to populate data for breakers. In general, the industry is moving toward node breaker topology for transmission and operations planning applications. It's important to understand PSSE supports this topology in an intuitive way. With node breaker, you can use an automatic substation generator. You can generate the configurations for a substation by giving it a number, a name, selecting associated buses, and selecting from one of the common topology templates. Then click Automatically Generate Station Diagram and Go. Another area of analysis with PSSE is contingency analysis, such as n-1-1. This is a contingency testing scenario where there are two outages that happen, but there is a chance between the contingencies for the system operator to make adjustments to the system. Another area of analysis in PSSE is the short circuit model. It's based on the power flow model, but results are calculated in a different way. With short circuit analysis, the user applies various faults at various locations on the system and then looks at fault magnitudes, fault currents, and so on. There are standards for various parts of the world, and you'll notice the ANSI standard is completely supported along with the IEC standard. The next area of analysis is OPF, which allows the input of cost tables, penalty factors, and constraints, allowing the user to optimize power flow objective functions. Dynamics is also a very common analysis. PSSE is known for its extensive dynamics library. For dynamics, some additional data is necessary. Let's open up a sample case for dynamics and then open another data set for the dynamics model data. We'll use the snapshot file save.nw. Once the file is open, you'll see various generator models. If you select a generator model, you can look at detailed data associated with all model parameters. To view the extensive dynamics library, open the PSSE documentation and view the Model Library Documents section. All models consist of block diagrams. Each parameter is stored with the data in the table for the generator model. Once you have all data necessary for a dynamic study, you can use the power flow model along with the dynamics data to simulate the system. Initialize the case and send the data to an output file. Once you run in a flat condition, then apply a disturbance, such as a fault on a generator bus. Next, run the simulation with this fault applied for the desired clearing time. Then apply the disturbance of clearing that fault. Now that you've run the dynamic study, you have a channel output file, which contains all the dynamic outputs. You can drag and drop these outputs to the plot to better understand the stability of the system. PSSE Dynamics is not just about simulating the machines and the controls, but also the relays and protection systems. There's a large library of protection models, and if you model the entire protection system in PSSE, then all post-disturbance actions can happen automatically in the simulation. These are just a few of the many features that come with Siemens PSSE to give you trusted benchmark results.
Siemens, ingenuity for life.